Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem paths to reach origin. So basically the problem says that we are initially standing at the point x comma y and we want to go to the origin. So starting from a particular point x comma y inside the grid, we have to go to the origin, that is 0 comma 0 cell, and we have to take two kinds of steps. So either we can do what? Either we can go on the left side or we can go on the upwards direction. So whenever we are standing, suppose at a cell x comma y, then from there either we can go in the upward direction. If we will go in the upward direction, so that is what? That is basically x minus 1 comma y. If suppose that we go in the left direction, so whenever we are going in the left, so the row remains the same, the column decreases by 1. So that will be nothing but x comma y minus 1 here, right? Now after this, the problem says that from each point you are allowed to move either in x minus 1 comma y or x comma y minus 1, as I've explained already. Then we have to find the number of paths from the cell x comma y to the origin. Now basically if you will see, so we have to try out all possible paths. Whenever we have to try out all possible paths, then the concept of recursion comes to our mind, because by using the concept of recursion we can explore all possible ways or all possible paths here. So let us try and write a bit of code for recursion here so that we can understand it better. So the very first thing is that if we are starting from a cell x comma y, that is there. So in this case, we can simply say that we will first of all return a recursive call. And also if you will see one more thing, so we have to take the modulo also with 10 to the power 9 plus 7, because otherwise the number of paths can be very high. So in order to keep the answer under control, we have to take the modulo with 10 to the power 9 plus 7. Now what we will do is, since you have to take the modulo, so I can declare a int variable. Let's say int mod is equal to nothing but 1e9 plus 7. So 10 to the power 9 plus 7. And initially we can start our recursion from x comma y cell. Now what we will do is, we will write this recursive function. So we'll write int recursion, and then we'll have, let's say, int x comma int y here. Now what are the base cases, right? Suppose that if I am in the grid, and what happens is, suppose that we are at a particular cell inside the grid. Let's say currently we are at this particular cell. Now what happens from this particular cell, if I will go on the left side, then I will go outside the grid. So you can see here that what happens is, whenever my y becomes negative, okay, whenever my y coordinates become negative, or suppose if I'm standing here and I go upwards from here, I'm only allowed to go on the left side as well as on the upside. So if I go on the left side, then my y coordinate might become negative, or if I'm going outside the grid by taking upward movement, then also I can go outside the grid. So the thing is that if my x is less than 0 or my y is less than 0, then in that case I will not have any paths, because suppose if we were initially at this cell and then we moved up and then we moved here, and then from here we are going outside the grid, so this indicates that it is not a path. So what we need to do is, if it happens that my x coordinate or y coordinate, any of them becomes negative, so this means that we are going outside the grid either from the upward side or from the left side. So that's why we will write that if x is less than 0 or y is less than 0, then there would be no path, and we can simply return what? We can simply return 0. Otherwise, suppose that if my x coordinate is equal to 0 and at the same time my y coordinate is also 0. So if I reach the origin cell, then we can directly return 1, indicating that we have followed a particular path, and by following a particular path we were able to reach the origin. So that particular path should be considered as one of the path. So that is why we are returning 1, right? Otherwise what we should do is, let's say we should write our number of ways as what? We will call the recursion for x minus 1 comma y, that is total number of possible paths by going on the upper side, and plus x comma y minus 1, so total number of paths by going on the left side. Now after that, what you can do is you can take the modulo of it with 10 to the power 9 plus 7. So let's take mod with 10 to let's take the modulus here, and then after that we can simply return the number of ways here, right? So this is how we can implement it using the recursive way. Now let us try and compile this code to check what happens here. I guess the compiler is a bit slow, so let's try and submit it. Obviously we will get a TLE error. The reason for that will be because currently we are using a recursive approach and there will be a lot of overlapping sub problems here. So if you will see here, the code is trying to get submitted here. Yeah, so you can see here that it is running fine. There is no error in the code. It was able to pass 10 test cases, but we got a time limit exceeded error. Why? Because currently the code is exponential. Why it is exponential? Because suppose if we are given a particular cell x comma y, so from that either we are calling x minus 1 comma y, or we are calling what? We are calling x comma y minus 1. So we are making these two calls here. So what happens here is, if we will make the calls like this, so suppose that initially we were given the cell 5 comma 6, let's say. So from here one of the calls can be that I can call for 4 comma 6, another call can be that I can call for 5 comma 5. Now from here what we can do is, we can call for what? We can call for 3 comma 6, let's say, and the other call can be that we can call for 4 comma 5. From here also we can call for 4 comma 5, and then from here we can call for what? We can call for nothing but 5 comma 4 here. So you can clearly observe one thing, that there are overlapping sub problem, because what we are doing is, if we are at x comma y, so one time we are calling for x minus 1 comma y, and one time we are calling for x comma y minus 1 here. So you can see this is an overlapping sub problem. So if a particular state x comma y is already calculated, I should not calculate it again, because currently what is happening, from a particular cell we have two choices. Either we can go on the left side, or we can go on the upward direction, right? So that is why the complexity would be 2 to the power n cross m, because you are repetitively calculating a lot of sub problems. So if we will apply dynamic programming here, indicating that if a particular state is already calculated, then we'll not calculate it again, we'll store its value and directly return it. So then the time complexity would reduce to what? It would reduce to order of n cross m. And for that I'll be taking a DP array of which will be 2D in nature, because I have to store the x and the y coordinate. So the space complexity would be n cross m as well. Now let's try and implement it using DP. So for that we just have to declare a DP array here and then pass it. So let's say what I will do is, I'll declare vector int vector of vector int DP, and let's say that I will declare a DP of x plus 1 comma vector int y plus 1 comma minus 1. So initially I have done what? I have initialized this DP with the value as minus 1, and why I have declared it as x plus 1 comma y plus 1? Because I want to store the DP of given xy as well. Okay, now now we can pass this particular DP array in this function also. So we'll pass vector of vector int ampersand DP, and we'll pass it in both the function calls as well. So let me pass it here as well as here, and we'll pass it in the main function also. Now what will happen is that we need to check that, suppose if after checking all the base cases, if the DP of xy, if it is what? If it is not equal to minus 1. Okay, if it is not equal to minus 1, then in that case what will happen? Then I'll say that if it is already calculated, because if it's not minus 1, so it's already calculated and stored, then we'll directly return this value. Otherwise what we will do is, we'll store this answer. So we'll store DP of xy as what, guys? As a number of ways, and then we will return this particular way. Okay, then we will return the ways here. I hope that you have got this clearly, guys. Now let's try and compile this code again, and we'll submit it. It should get submitted, obviously. So yeah, you can see here it is working fine on the sample test case because it is giving correct output. Now let's try and submit this to check if the code gets accepted or not. So you can see here that our code was able to pass all the test cases. I hope that you have understood this particular problem clearly. This is just a variation of another problem in which you have to always start from 0,0 cell and you have to end at the bottommost rightmost cell. Here you are starting from a cell x, y, and you have to always go to 0,0 cell. So in the other version of this problem, you can always take rightward and downward movement. But in this version, since you have to move to the topmost leftmost cell, so that's why you have to take left and upward movement. I hope you have understood this clearly. Please make sure to comment understood in the chat. And thank you for watching this video. Keep coding.